Yeah.
3D nanoscale optical disk memory with petabit capacity.
Yeah. So for those of you that don't know, like hard media storage is still a thing, and it's still tape backups are still used today. For those that don't know, a DVD is a little round disc that you use to play. Uh, you can play movies on. You can store data, different things like that. Um, I know we're getting away from media storage, but this is cool because again, this is another one. Researchers in China, they've developed a revolutionary 3D nanoscale optical disc memory with a staggering petabit capacity. To put that into just for those of you that understand DVDs, you could potentially store 125 terabits of data on one disk, which is the equivalent of 15,000 DVDs. One disk can store 15,000 DVDs. The key to this is in the innovative use of, and this is a long word, but aggregation induced emission dye doped photoresist, AIEDDPR, and that's the recording medium. So the material exhibits unique properties that allow for ultra high density storage through a process called volumetric nanoscale optical data storage. Again, big words, a lot of things, but essentially what it is what they're doing is they're leveraging femtosecond laser beams and a deactivating beam. So the researchers can precisely write and read data at the nanoscale level, which is breaking through the diffraction limit barrier that was traditionally constrained for optical storage density. So what the writing process relies on is two-photon absorption and polymerization inhibition, which enables the creation of recording spots with sub-diffraction limited dimensions. So essentially all that means is that they're able, so just so that people know, DVDs are limited to one or two layers max. This is called 3D nanoscale optical disc because they can write to multiple layers, hundreds of layers. So the key to this is that, so talking about all that is their ability to store data in hundreds of layers within the film, and the AIE DDPR is the film that they're the each layer. So it extends the recording architecture from planar, which is flat, to three dimensional, which it's more than three dimensions, obviously, because we're talking hundreds of layers, but it is three dimensional because you're storing it multiple different vertices, if that makes sense. So they did demonstrate successful recording and readout of data on 100 layers with a layer to layer distance of just 1 micrometer, which is crazy. So the potential is truly remarkable. They can stack multiple nanoscale disks onto arrays. They can, like, you can, the it's endless. So obviously, further improvements are going to be needed for reading, for writing speed and efficiency. I remember back in the day when they first released writable CDs and writable DVDs, it would take hours to write, and I'm sure this takes just as long, if not longer. But we're talking a lot of data. So, and again, we're talking with very expensive equipment as well.
Yeah, this looks amazing. I was highlighting some of the articles on the side as we kind of went through it, where like these are
Yeah.
articles referred to in the other article, and this one is 100 layer error free 5D optical storage by ultra fast laser nanostructure in glass. And this is interesting when you're talking about how many layers. uh, you know People maybe at a consumer level don't really understand how much hard drives and data centers and space is used in optical storage. We used to have, towers and towers of storage area networks that would replicate across sites and sites to do all this stuff. And then you've got online, near online, and offline storage for backups and stuff. Where does this fit in that tree of, would this be online or be near online, meaning, it takes a little longer to access when you store stuff this in a, some sort of array, or would this be high speed access?
So right now, definitely not high speed access. Like, we're not talking about like RAM speed or even even hard disk speed. I don't think. I think this right now would be more for say backup kind of technology. So again, because it's got a lot of storage, um, and think about it like this: like DVDs and Blu-ray discs, they were never used for real time. But you never know with the technology. I don't know much about the laser that they're using. I don't know much about too much more about the film, other than what's in the article. But it could essentially this is more for data archiving rather than like reading and writing in live, if that
Yeah,
makes
and
sense.
I'm followed the article down, and I'm highlighting some stuff that supports what you're talking about as you're talking. Okay, so
Hmm.
what are some of these potential applications of these 3D nanoscale optical disk memory technologies? I take a step back and say, great. I mean,
Yeah,
I, as a person who built multiple server room data rooms in, understand this. I built them
yeah,
for Mercer, I built them for Deloitte, I built them for
yeah,
large corporations. But um, what's the potential application outside of pay a server room for this type of thing?
yeah. So just so you guys know, and don't ask me how I know this, but a a HDR 4K um, Dolby Vision, Dolby Atmos file, I think is like uncompressed is like hundreds and hundreds of gigabytes. And so this could enable more uncompressed, because you know when you compress a video file, you lose some of the quality. So this could potentially enable um, full quality, uncompressed kind of. That's just one that came off the top of my head. But the other thing is too data centers and cloud storage. So with like we're talking tons of data in these generated by businesses, scientific research, consumer applications. Um, the data centers themselves, and you know this, are grappling with the challenge of storing and managing vast amounts of information. So this technology could revolutionize data center architectures, enabling more efficient, cost-effective, and long-term archival storage solutions. So again, a lot of this is more kind of storage. So um, scientific research and supercomputing. So the ability to store and access huge data sets efficiently is crucial for advancing research. So it could enable more comprehensive data storage and analysis capabilities for supercomputers. Um, if we want to talk about aerospace and defense, they often have to deal with large volumes of sensitive data, including satellite imagery, surveillance footage, things like that. So the high storage density and potential for secure data encryption could make this technology valuable for storage in space and things like that. Even personal data storage and backups. Like imagine, well, I guess I only have about 20 terabytes worth of data, but like imagine just having unlimited. Like you have one disk that can store your whole life, your whole family's life, even more, and then some.
Yeah, and it's talking about lifetime storage, unlimited lifetime storage at room temperature, which has always been a concern for a lot of the mediums, yeah, especially from a demagnetization point of view after a number of years. Do they
Yeah.
like it, is this really a lifetime storage, or is it just a word they use to say it's longer than what we're using today?
Well, there is a potential because of the medium they're using and everything like that. So first off, chemical stability. So the film that's used, the AIE DDPR, as the record, it's a polymer based material and it exhibits excellent chemical stability. So unlike magnetic or optical media, which is DVDs and hard drives, they can degrade over time due to oxidation or corrosion. The cured film in this AIE DDPR, it's highly resistant to chemical reactions that could compromise the integrity of the recorded data. The other thing is thermal stability. So they conducted extensive temperature stress testing on the recorded discs, exposing them to temperatures as high as 130 degrees Celsius, and for those Americans, 266 degrees Fahrenheit for prolonged periods. And the results showed minimal degradation. So, really cool. Environmental stability. Again, we're talking physical robustness. So the optical discs are generally more resistant to physical damage compared to magnetic tapes or hard drives. So the film's solid state nature and encapsulation within the protective casing that further enhance its physical robustness. So it's really really cool.
So, do they talk about performance? I'm trying to find in a few of these articles because they're all kept referring to other articles doing different
Yeah,
similar things. Um, what is the performance from? It's great that we can store a massive amount of data, and as we move into quantum computers and AI and training these things, we're talking about literally warehouses full of racks and racks and racks
yeah,
of hard drives.
yeah.
Um, this potentially could shrink that significantly, but what's the performance?
That yeah. Again, I don't know. So the current process used in the scanning femtosecond laser beams to record data spot by spot is time consuming right now, obviously, because it's newer technology, right? And so that's going to be a big thing that they're going to have to. And um, this is just based on the article. So um, they don't get into specific um, performance, and makes sense because we're still at that early stage, right? Um, and yeah, I'm not sure based on the article. The readout speed and data rates were not addressed in the published work, so I'm guessing it's really slow, like slower than we would expect.
Yeah, it says here, but the drawback is relatively low writing speed of zero point 0.2
Kilobits per
kilobits per
second.
second, minus one, whatever the minus one
Oh,
means in that particular to the
yeah,
power of. So
yeah.
that's why I was curious. I saw a reference to that. 9 times higher, 43 times higher recording speed. So they've done some stuff to get it up, but I'm curious because, and I'm also, it's fun that they used the Hitchhiker's Guide to the Galaxy as a test for all of this. They were they did multiple recordings of audio recording, I guess, of the Hitchhiker's
Yeah.
Galaxy to, um, so it's very interesting. The cool that it stays that long. A corresponding data capacity of 350 gig per 120 millimeter disk and data writing speed of 8K per second. Um, yeah, so it's going to be slow at least now, but of a
What I think
magnet.
they might. Sorry, go
Go
ahead.
ahead.
What I
So
think they might do is start with a lower capacity disk that has higher read and write with a different laser, and then upgrade until they get to that max capacity, which I think is what they did with DVDs. Yeah, I can't remember, but
so how soon is this? It always comes down to how
I'm
quickly we're going to see this in like a, say, let's just say high end data centers.
I'm guessing 10 years.
And you probably said this, but as I was researching it, I'm trying to figure out. You probably didn't say it in the way I want to hear it, which is, okay, we can fit, you know, several hundred hard drives in a standard rack right now in an
Yeah,
array in the storage area network. Side by side one of these, how much more storage can you do in the same
yeah.
type of thing? Is it 10 times, 1,000 times?
So DVDs with a single layer are 4.7 gigs. If they're dual layer, they're 8.5. Blu-ray single layer is 25 gigs, dual layer is 50 gigs, and this 3D nanoscale optical disc is 125,000 gigabytes.
So one CD size disc is how big again?
No, one DVD size disc, which is 125,000 gigabytes. The Blu-ray is 50 gigabytes.
125,000 gigabytes. Okay, so 125,000. So it's short of a terabyte.
Yeah,
Okay,
well, way
I'm just
short of a
trying to,
terabyte.
yeah, I'm just trying to get it in my thing. And that we would multi-layer these discs and say have some
Yes.
sort of hard drive unit. Like
No,
I would,
it's no, it's all in one disc. So it's a thicker disc that has multiple layers within that one disc.
okay, so
So one disc could hold petabytes.
Yeah, that's what I was getting at. So we can hold that is that 125,000 gigabyte is per layer.
Yes.
Okay. So
Yeah, I'm just comparing it to the single layer Blu-ray. So single layer Blu-ray is 25 gigs. Single layer DVD was 4.7 gigs, and single layer 3D is 125,000 gigs.
and so you can do 100 of those in what we're going to say as a again a DVD size disc,
Yeah,
maybe a little thicker,
yeah,
just so you can put whatever you need between the layers to make sure it's discernible. So now you're talking petabytes on one of those.
yeah,
And so you're talking about, I don't even know, is it exactabytes beyond petabytes? I can't remember what the. Uh,
yeah. I think it's exactabytes.
so we're really talking about taking storage to a huge new space.
Yeah,
So
yeah.
when we talk
We're
about
essentially exponential here.
quantum computers,
Hmm.
analyzing the state between 0 and 1 being infinite number of possibilities between 0 and 1 versus common computers, which is just 0 or 1. Having this kind of storage really makes a difference because that 0 and 1 is not one thing anymore. It's an infinite possibility of things.
Yeah,
And when you say, all right, we want to use quantum computers to solve these huge world problems, you're talking about calculating every possible possibility and putting all that together and figuring that out. So, and
and that
feeding
data.
these
Yeah,
AI machines.
yeah, and that data can be stored on these disks, which is awesome.
So naturally, what happens with this has happened with DVDs and whatnot. We can get more storage. Then they eventually apply this similar technology or idea to hard drives or solid state technology. Do you see this being able to leap
No.
into no?
No, because if you think about like DVDs and CDs, it's the same kind of based on my understanding, it's the same type of storage medium kind of thing. It's just a different material and different laser. So I know I think this is more for archival and retrieval kind of thing. More because I don't think you can do multiple read and writes to this. I think it's one. Well, unless yeah, maybe you could, but um, unless it's a newer technology then which it is, but unless it's a technology that can handle multiple reads or multiple erases, then I think we're talking more like read, because I know there was rewritable
Like a worm
DVDs.
drive. Yeah,
Yeah,
this feels more based on everything I've read. It feels more like a worm drive than anything else.
yeah,
Um, which is interesting because now we say, all right, um, now we get back to a blockchain immutable ledger kind of storage format because it can't be changed once we record it, and it becomes an interesting other piece that you can deal with, right?
yeah,
Like from a all right, this is immutable storage. If we want this as a corporation or as whatever, so that people can come here and see everything that's ever happened transactional wise on every email that's been sent or whatever, this is
yeah,
great technology for that.
yeah, this is
However,
for long-term storage. Yeah, yeah,
most corporations aren't doing that kind of stuff for legal reasons anymore. They're flushing this stuff as quickly as they possibly can.
yeah,
Um, you only keep
yeah,
6 months a day, whatever they're legally required from an email point of view. Otherwise, it's gone.
yeah,
Um, because any discovery means that any random employee could sink you
for
because they
sure.
emailed some stupid thing about somebody. It's like,
Yeah,
man. Yeah, so this is really cool. I love what this is going, but it really isn't going to be. This is your mostly offline storage,
yeah, yeah, exactly.
and but the possibilities are endless. And I got a 8 terabyte drive here at home that I used to back up, and I'm thinking about I'll get a new one this year. But these things are at a whole new level.
Yeah,